Hello, students. This video will cover Saxon Algebra 2, Lesson 30.E, which is called 180 degrees in a triangle. This is something that we've known for several years, but you reach a point in mathematics when you have to learn how to prove every single little thing, and it's actually quite fun. In the beginning, you're going to be proving things that you know well, like this, but later on, you're going to be given different diagrams and have to prove that certain angles are equal or certain figures are congruent and all different kinds of challenges like that. So we're going to work again with Euclid. Well, this video, we're going to prove that the sum of the interior angles in a triangle is 180 degrees. And we're going to start with Euclid number 5, which says, given a line N and a point P not on that line, there exists in the plane of N and P one and only one line through P that is parallel to N. Okay. What in the world is this talking about? We can draw it like this. Given a line N, here we go. I will give you this line N, and I'll make it a line by putting arrowheads on both sides of it. There's line N. And here is point P. It is not on line N. There exists in the plane of N and P. The plane that N, line N, and point P are in is the plane of this paper. Remember, planes have width and length, but no depth. So this says that there exists a line through P parallel to N, one and only one. So I'm going to use my ruler here to kind of, I drew that a little bit, but this is going to be kind of parallel to N. And I'm going to draw that line. There's the one and only line in that plane that is through point P and parallel to N. Now, you might ask, how does that get us started with our proof? Well, when you do a proof, we're going to be proving things about triangles. So we want to draw any old triangle. Since I got this ruler here and I'm all, excited to use it. So I'm going to just draw any old triangle. Because that looks like a isosceles triangle. We don't want to just prove something for isosceles triangles. So I'll try to make it a little bit more of a scalene triangle. So here we have any old triangle. If we can prove this, that the sum of the interior angles in any old triangle is 180 degrees, and that means that the sum of the interior angles in every triangle is 180 degrees. So here's our triangle. And let me also say that many proofs include a diagram. Let me just say that there's 5 parts to a proof, and one of them is the diagram. So this line right here, the base of this triangle, we're going to call that, if we extended it in both directions, that would be a line. So that's going to be our line N. And I think you can see what's going to happen. The vertex of that triangle is going to be point P. And therefore, there is one and only one line through the vertex of that triangle that is parallel to the base of the triangle. And again, using this ruler, it's almost exactly the width of the ruler. How did I do that? Okay, here's the line that we can draw through P that is parallel to N, and I can make them parallel even if I didn't do a good job with the ruler by putting these arrowheads. That's the symbol that those two lines are parallel. And that's going to become very important in our proof. So we have that all set up, and I'm going to use the angle designations from the text. So that makes this angle A, and the vertex angle is angle B, and the third angle is angle C. All right, we're ready to go. And we've used Euclid to get this far, but now we need the theorem that's on page 138. That theorem says, when parallel lines are cut by a transversal, the pairs of opposite interior angles are equal. So let's unpack that a little bit. This might be review, or it might not. So I will draw parallel lines. They're little squirrely parallel lines like I draw, and I will draw, they are cut by a transversal. Now, you can see 1, 2, 3, 4, 5, 6, 7, 8 angles have been created by that transversal, but only the angles in here are interior angles. So if I isolate this angle and call it X, what is its opposite interior angle? It's the angle that's on the other side of the transversal and hooks to the other parallel line. So it's this one. I'll call it X prime. So X was the angle we started with, the one on the other side of the transversal and connected to the other parallel line, the opposite parallel line, is an opposite interior angle. And according to this theorem, when parallel lines are cut by a transversal, the pairs of opposite interior angles are equal. Let's apply this to our diagram of the triangle. Okay, so what we have up here, angle A is almost in the exact same location as angle X down here. And so we want to look, we can think about this side of the triangle is a transversal cutting through these two parallel lines. So angle A is going to be equal to the angle on the other side of the transversal that hooks up to the other parallel line. So it's going to be equal to this one. That is the same as angle A, has the same measure. So now down here, here's two more parallel lines made parallel by the addition of those arrowheads. And here's a transversal going that way. Here's where the interior angles are going to be, because this is the interior of the parallel lines. And so we're going to look right here and call that angle Y. It's in the same position as angle C in the triangle. And it's equal to the opposite interior angle. It's on the opposite side of the transversal, and it's connected to the opposite parallel line. So this Y and Y prime are equal, which shows us up in here. We have these two parallel lines, and now we're saying that this side is the transversal. So here's the interior. So this angle C is equal to the opposite side of the transversal, the angle made with the opposite side of the transversal and the other parallel line, it's this one, C. And now you can see by Euclid, we know that this red line is a line. And we can now see that it makes a straight angle that's divided into 3 sections. So A plus B plus C equals 180 degrees. There, I proved it. I hope this video helped you to understand lesson 30.C, and I'll see you in the next video.